A programming language, in simple words, is a system of interpreting some symbols or characters in a certain way to create a sequence of commands understandable for the computer. We could provide inputs to our programs in two ways: text input or visual input. Text-based programming languages are of course traditionally what we think of when talking about programming. What happens is we create instructions one by one with the specific end result in mind, an output of sorts. That way our little program starts to grow, gain functionality, mature, and eventually become functional and able to produce the output we planned in the beginning. This is the moment when we need to consider how we get from here, just having a bunch of instructions, to an executable program running on our computer. Computers are uncomplicated by nature. They speak the language of ones and zeros, on for 1 and off for 0, electrical current for 1, no current for 0. The program we just wrote is something that we understand, but the computer does not. To bridge that gap, we have something called machine code, or more plainly, binary, that name rightly suggesting we are dealing with ones and zeros. This is exactly what we need to execute the program on the central processing unit, the CPU, the processor in other words. Access to CPU is governed by something called the kernel, which manages access to physical resources of the computer. So now we have the full view of the journey our instructions take to be finally executed by the computer. There is just one more thing. How did we end up with machine code version of our program? It certainly weren't us who wrote all those ones and zeros, right? This is literally where the magic happens. The process of taking a human-readable program and translating it to machine code is called compilation. And here, there are two main styles of handling compilation. Compilation of an entire program and interpretation line by line. Let's look at interpretation first. The interpreted programming language of our choice has something called an interpreter built into its architecture. This is to say, it comes bundled with an interpreter. What it does, it takes a single line of our program and firstly runs various checks on it. For instance, if the syntax is correct, if there are no indentation errors and alike, and only then proceeds to compiling that code to binary, which is then given for execution by the CPU, which then returns an output. Interpreted languages are traditionally slow because of this, because the code needs to be run line by line. An alternative is compiled languages. Let's take a look at how they work. Here, the difference is that the compiler takes the entire program at once, runs similar types of checks for errors, and outputs binary for the entire program, which can then be run on the CPU. The very important difference here is that the CPU will have had the entire program to go through in one go. It doesn't need to output the result of executing a single line of code and wait to be instructed further. It can go through the entire thing right away. Okay, you might be thinking, if compiled languages are so much faster, why bother with slow interpreted languages? And you'd be right. Before the dawn of the internet, compiled languages were pretty much the golden standard. Let's take a look at differences between interpreted and compiled languages. Firstly, let's consider where physically we can run both. Because interpreted language does come with its own interpreter, like a foreign official with their own translator, Such language can be run on any platform like the Windows, Mac or Linux. The same is not true for compiled language. Each platform does need a compiler dedicated specifically for it. This is especially important on the internet, where a web application could be run on any machine. Not sure what a web app is and how it works? Don't sweat it. The entire next chapter is dedicated to web apps and understanding them. Interpreted languages are faster to develop a project with. After you've made some changes, you can run your program pretty much instantly, whereas a compiled language project would need to be recompiled in its entirety. This really adds up with scale of the project. And lastly, an interpreted language is compiled on the go to machine code. The source code files and their sizes are smaller compared to binaries of compiled language programs.